recording it. Okay, so who remembers what it means to be collinear? Somebody remembers from chapter 1. What does it mean to be collinear? I know it's been a while. Thomas.
Be on the same line.
Good. It's points that are all on the same line. And if we're talking about points that all exist on the same line, shouldn't we have the same slope? Shouldn't we always have the same slope for the line? Okay, so what we want to do to figure out if the points are collinear, oops, what have I done? Okay, to figure out if the points are collinear, we are going to check the slopes. And guess what? If the slopes are the same, then they're collinear. If the slopes are different, then they are non-collinear, exactly. So I'm going to check the slope for -6, 5, and 1, 7. And remember, how do we find slope? y2 minus y1 over x2 minus x1. So I'm going to call the first parenthesis x1, y1, the second parenthesis x2, y2. So then we are going to have 7 minus 5 over 1 minus -6. Seven minus 5 is 2. What's that double negative make? A positive. The double negative makes a positive. So 1 plus 6 is 7. So this is the slope. We need everything to have a slope of 2, 7. Now what should I check? So I checked -6, 5, and 1, 7. What should I check now?
The y-intercept?
No, we're still just checking slopes.
Oh.
So I checked the first 2 points.
Oh, the third point.
Good. I could do 1, 7 and 15, 10. Do we agree? Let's check those slopes. So I'm going to say this is x1, y1, x2, y2. So our slope is going to be 10 minus 7 over 15 minus 1. What's 10 minus 7? 3. What's 15 minus 1? 14. Is 3 over 14 the same as 2 over 7? No. So are these collinear? No. Are the points collinear? No, they are not collinear because they have different slopes. Now let's say, for fun and games, that this did end up being 2 over 7. Would that have been enough to say all the points are collinear? No, I still would have had to check what else. So I did -6, 5, and 1, 7. Then I did 1, 7, and 15, 10. What would have been the last thing I had to check? Ollie.
-6, 5, and 15, 10.
You got it. -6, 5, and 15, 10. But the minute we get one that's not the same, we could just stop and say, nope, they're not collinear. We're done. Okay, so the next question is asking, does the point 4, -1 lie on the line 3x minus 2y equals 10? So we remember what we told you. The lowercase m represents what? Slope. The b represents what? Y-intercept. Who remembers, what did we say x and y represent? Ali? Say it one more time. All the points on the line. So when I'm asking you right now, does this point lie on this line? What you want to do is you're going to plug in x and y, and if the equation holds true, then it is on the line. If the equation is not true, then it's not on the line. So let's go ahead and do this. So we have 3x minus 2y equals 10. So here's my x and my y. I'm going to plug in x and y. So now I'm going to have 3 times 4 minus 2 times -1, and we want to know, does that equal 10? So we have 12. What's a -2 times a -1? +2. Does 14 equal 10? No, this is not a true statement. So does the point lie on the line? No. The point for -1 does not exist on the line. Or does not, or is not on the line. We could do that. Yes, Brenda.
So I turned it into the equation y equals mx plus b. Like I rearranged the equation. And I still got 14. You can still.
Yeah, it still works even if you rearrange the equation. Absolutely. Alicia, did you have a question for me?
No.
You're good? Yeah. Okay, let's keep going. Okay, so these are a little bit more involved, but these are better questions. These get us thinking. So now we want to find the equation of the line width. So with a slope of 3 and an x-intercept of 5. So whenever I ask for an equation of a line, do we agree I'm setting up the format y equals mx plus b? And we need a number for m, and we need a number for b. And once we have a number for m and a number for b, we're good with the equation of the line. So once again, I'm going to write this out. I need y equals mx plus b. What does m represent? Slope. What does b represent? Y-intercept. In the first problem, are they giving us the slope? Yes. So this is going to be y equals 3x plus b. Is the y-intercept and the x-intercept the same thing? No. Y-intercept and x-intercept are not the same thing. But the x-intercept, just like the y-intercept, what are they? They're not lines. They're not segments. What are they? They're points. So when they say the x-intercept is 5, isn't that the same as saying, well, there's a point on the graph that's 5, 0? So I need to find b. That's what we need to do. We need to find a b. How am I going to find a b? Well, don't x and y represent all the points that lie on that exist on the line? So can I plug in 5 for x, y for 0, and then solve for b? That's what I want to do. So we are going to say 0 equals 3 times 5 plus b. So 0 equals 15 plus b. So what does b equal? -15. Do I have an m? Do I have a b? Yes, now I have the equation of our line. The equation of our line is y equals 3x minus 15.
What does the y stand for again?
The y and the x combined represent all the points on the line. So like y are all the y coordinates, the x are all the x coordinates of all the points that exist on the line. So it's always changing. Okay, so now I'm going to make this a little bit more difficult. So now we're creating the equation of a line. So again, I want an equation of a line. What format is that? Y equals mx plus b. And what do we need a number for? We need a number for m and a number for b. Well, I don't have an m and I don't have a b, but I do have 2 points that exist on that line. If I have 2 points, what can I always find given 2 points? Their what? Their slope. Ali, is that what you were going to say? Yeah, so how do we find slope? y2 minus y1 over x2 minus x1. So I'll call the first parenthesis x1, y1. I'll call the second parenthesis x2, y2. So now we are going to have 1 minus negative 3 and 4 minus 7. What does a double negative make? A positive. So we are going to end up with 4 over negative 3. Is it okay if I take that negative out of the denominator and give it to the numerator instead? Is that okay? Absolutely. You could always take a negative out of the denominator and just assign it to the numerator instead of the denominator. So now I'm going to go back to my equation, and I have y equals negative 4 over 3 x plus b. Is this good enough? No, we said we needed a b now, right? Any ideas on how I can find the value of b? 2 people think they know? 3 people? 4 people? 5 people? Johnny?
You can plug in one of the points that was listed for x and y.
You got it. We can take, remember, don't x and y represent all the points on the line? So I could take one of these points and plug it in for x and y. So which point do you want to take? I'd go with 4, 1. So I'm going to go with 4, 1. I'm going to say 1 is equal to negative 4 thirds times 4 plus b. Are we okay so far? A. Now I'm going to multiply. So 1 is equal to negative 16 over 3 plus b. What do I have to do to solve for b?
You add the 16 over 3 on the other side?
Yeah, we have to add it to the other side. So now we're going to have 1 plus 16 over 3 equals b. You need to make a common denominator. We need to make a common denominator. So what am I going to get? 3 over 3 plus 16 over 3 equals b. Isn't that 19 over 3? Who said what? What's wrong? We just made a common denominator. What's wrong?
You're just going very fast.
I'm going too fast? Okay, I'll slow down. Did you understand we added the 16 over 3 over?
Yeah, because you need to get b by itself.
Yep, we need to get b by itself. And then what did I do?
You have to turn 1 into 3 over 3, so you need a common denominator or bad.
Yep. And then we were left with 19 over 3. Better? Okay, so do I have an m? Oh, yes, Bryce.
How'd you get the 19 over 3?
Did you know we had to add 16 over 3 on both sides?
Yes.
So that brought us to this step. So we're at 1 plus 16 over 3. Well, I can't add a whole number in a fraction. I need the same denominator to add. So this is really 1 over 1. So to make a common denominator, not 1 over 3. This is 1 over 1, so I had to multiply top and bottom by 3 to create a common denominator. So then we have 3 over 3 plus 16 over 3. Keep the denominator the same, add the numerators. That's how I got 19 over 3. All right, I have an m, I have a b. So y is equal to negative 4 thirds x plus 19 over 3. What's wrong, Brenda? The negative 4 over 3?
We got negative 16 over 3.
That was our b, right?
Yeah.
No, we got 19 over 3 for b.
Oh, that's... Oh.
The 4 over 3 was for the m.
Yeah, okay, that makes sense. I wrote the wrong thing down.
Okay. Can I erase this? Yes, I can erase. Anybody still copying? No? Okay. Okay, for this next one, don't write. I'll give you time to write. Just listen. I promise I'll give you time to write. Okay, so for the next one, it's saying we want to come up with an equation parallel to this whole hot mess, and that has a y-intercept of 1. Okay, well, we want an equation of a line. Isn't an equation of a line y equals mx plus b? Again, I need a number for m, I need a number for b. Now, it's saying our line that we're coming up with is going to be parallel to this whole thing. Well, what do we remember? Think back to yesterday's lesson. Lines that are parallel, there's something the same in them. What's the same in lines that are parallel? Zach? Their slopes are the same. Right now, the way this is written, am I able to identify the slope? No. Can I manipulate this equation so I can identify the slope? Yes, I need to make it look like y equals mx plus b so then I can identify the m. So let's do this now. So you guys write this down, write y equals mx plus b. And then we're going to have, I'm going to write down the 4 times the quantity of y minus 10x equals negative 24. I need to make this look like y equals mx plus b. What are your suggestions on how we're going to do that? We need to get y by itself. Allie? Sure, we could start off by distributing the 4 if you want. So we're going to say 4y minus 40x equals negative 24. My goal is to get y by itself. What should I do now? Rach?
Add the 40x to the other side.
Perfect. We're now going to add the 40x to both sides. So we're going to have 4y. Which should I put first, the negative 24 or the 40x?
40x.
The 40x. We want the x first, minus 24. And then our last step would be to divide by 4 under everything. So now we have y is equal to 10x minus 6. Okay, I'll give you a minute to catch up before we talk some more. Okay.
Wait, sorry.
Mhm.
Would it be? Oh wait, never mind. I was wrong.
You're okay? Okay, so now let's talk about this. We agree that this equation is the same as this, yes? They are the same. So now the line we're coming up with has to be parallel to this line. And Zach told us parallel lines have the same slope. So what is the slope of our new line? What is the slope, Mia? 10. Our slope has to be 10. So we're going to say new line slope is equal to 10. Okay, so our new line has a slope of 10, and then it says it has a y-intercept of 1. Well, isn't that all we need, the slope and the y-intercept, to create an equation of a line? That's all we need. So our equation of the new line is y equals 10x, and then what do I do? Allie? Plus 1, you got it. And this is our answer. Can I go on to letter D? Okay. So now, stay with me for a second. Now we need an equation of a line that has an x-intercept of 8 and passes through the point 8, 5 root 2. Don't worry about that 5 root 2. Let's just think about this. If it has an x-intercept of 8, how do I write that as a point? Allie? 8, 0, and the other point is 8, 5 root 2. Please tell me you noticed something about these 2 points.
The x is the same.
Good. Their x coordinates are the same. Is that normal for a line to have the same x coordinates? That is not normal for the line to have the same x coordinates. So this is a special scenario. It's either going to be a horizontal line or a vertical line. It's either going to be horizontal or vertical. How do I know this? Because points on a line never have the same coordinates. So if the x's are the same, it's a special case. What are our only 2 special cases? Vertical or horizontal. Let's give this a sketch. Let's sketch this to see. So we have 8, 0. And then 5 root 2, 1, 2, 3, 4, 5, 6. It doesn't matter because this is just a sketch, right? What happened here? Why did my numbers move? There you go. Okay, so we're at 8, 0, that's here. And then 8, 5 root 2 is somewhere around here. If we connect these points, what kind of line is this? A vertical line. So you tell me, what's the equation of a vertical line? X equals or Y equals? Katie? X equals. So it's going to be X equals. Oh, this is just flipping out on me here. What's going on? All right, we're going to have X equals the common X coordinate. What was the common X coordinate? 8. So what's the equation of this line? X equals 8. That is our vertical line. And how did I know this was going to be a special case? Because of the common 8s. Okay, next one. We want to come up with an equation of a line. So again, just pay attention to me, then I'll let you write down. I'll let you finish writing down D. So now we want an equation of a line that's perpendicular to the y-axis and passes through the point 11 root 3. Don't worry about the root 3. It doesn't matter. Let's just figure out what this might look like. Do we agree that's our axes? The horizontal one is x, the vertical one is y. So now if I want to be perpendicular to the y, what kind of line has to be perpendicular to the y? Alicia. They make right angles, but what kind of line will make right angles with the y-axis? A horizontal line. So do we agree we need to come up with an equation of a horizontal line to make those right angles? Okay, you could write this down. You could draw our sketch. And then we'll talk. Okay, so what's an equation? Since we now know we need a horizontal line, what's an equation of a horizontal line? What's an equation? Ali, your back must hurt. You're holding up the class. Come on, guys. Rach? Y equals a number, right? Y equals a number. All right, but this time, last time we're like, okay, well, x is going to equal the common x coordinate, right? Well, this time it's just going to be y equals the y coordinate. So what was the y coordinate here that it passed through? Brenda?
Root 3.
You got it. Y equals root 3. All right, write that down.
Is that perpendicular to the x-axis? Would it be like the opposite?
Exactly. If it said, great question, if it said perpendicular to the x-axis, we would do the opposite. So we'd make a vertical line, so it would be x equals the x coordinate, which would be 11. Can we move on to letter F? Okay. So once again, we want to come up with an equation of a line that contains these 2 points. What do I really hope you realize? Alicia?
That they have the same y coordinate.
They have the same y coordinate. What does that mean? It's going to be a horizontal line. Very good. If we do not know that it's going to be a horizontal line, can we come to the conclusion at least that it's going to be a special kind of line, either horizontal or vertical? And how would we know? You can sketch it. If you don't know what kind of line it's going to be, you can sketch it. So we have 2, 5. So let's say this is 2, and then 24 would be all the way down, right? All the way down the number line, I'll put it there. So 24, 5. If we connect these two, isn't that a horizontal line? All right, so if it's a horizontal line, is that x equals or y equals? Alexis? Y equals what? 5. Y is going to equal the y coordinate, which is 5. I can only imagine we have only a few minutes left, right?
1 minute left.
1 minute. Okay. Well, I am done with the lesson. You do have homework. I'm going to assign the homework. It's a worksheet. So I will assign the worksheet. And happy Thanksgiving.